So here we are going to do the 16 by 8 divisor, where we have declared the 16 bit of dividend here and 8 bit of divisor here. So this is the Verilog code of that. So now we are going to compile this. So I am going to compile like this. So the compilation is going on. So the compilation, as if you can see here, it is going to be complete correctly. So now it is going to complete it. Okay, so fully successful it is. Now what we need to do, as we need to make a module of it. So just we are going to this program here and we are going to create the symbol out of it. So we are going to create it, and you can say the creation was successful. So now we have to use the setup of it. So for that I am now going to make a new project. So here I am going to do the new project, and from here I already make a folder of it. So I am testing here and I am just writing as tb for test bench div 16 and finishing it. Now here we do not have anything, so we just need to call it as a block diagram file. So we are calling it, and here we need to call the block diagram what we have generated earlier. So if we go to this part like quartus1 dv1, so we have created this one. So we have this block diagram of it. So now we need to use the input and outputs. So we are going to use the inputs 1, 2, 3 and 4. Similarly we need to have 4 outputs, 1, 2, 3, 3 outputs, 3. Now we need to change the name of it. So we are going to name this clock. Here we are going to name it reset. Here we are going to dividend, and it is of how many bits? 16 bits, so 15 0, and this is our going to be divisor, and it is of 8 bit, 7 8 bit. Now just we need to connect from here to here. This is going to be very simple. The start we have to also mention. So we are just not right now doing the start thing. Okay, now here we need to write the out as a question, and it is of 16 bit. This is remainder of 8 bit. And this is after completing getting the, so this is done. We also need to include one input, which is start. This is complete. We have saved. Just we need to do the compilation. So it will give some error because we do not have. So this is with having 3 errors. So what is the error? It will not able to find this block, which is this one, div. So from here we need to go to the add, and we are going to add this. So here this we need to add in it. After adding it, we must have the correct one. So now we were able to see that this is successful. Yeah, this is going to be successful. So now this is successful. So we need to create a test bench so that we can test it. So we are going to do the university program here. From here we are going to insert the nodes, node finder list, or okay. So now what we need to do, this is clock, this is reset, this is start, and these two are input. So for we are going to give the clocks. So from here we are going to give the clock having 10 nanoseconds. Okay. Reset. First we are going to give this reset this much uh, to be high. After that it will go to 0. And from here we want to start it. Make it 1. Now if we are going to give the, these are the, if you see, unsigned binary decimal we need to take. So just suppose if we are using the value like 15 and we are dividing by 4. Okay, and just we are running the simulation from here. Okay, so the simulation is completed, and after that if we see it, so after done, right, so our program is done here. So after this we will get the result. So this is our result here. So when you move to the cursor, you have 15 which will divide by 4. So quotient would be 3 and your remainder would be also 3. So 4 into 12 plus 1. So the program is correct right now. Okay, so you can check by using different combination. Okay, so after start, how it is taking too much of cycle. So this is the intermediate. So we do not need to see this. Just when it completes, it will give you signal done. So after this done, you need to see the quotient and remainder value. So I guess the working is complete. Okay.